Sa video natin ngayon, we will be deriving the kinematics equations using calculus. Di ba meron tayong tatlong kinematics equations which you may be familiar with since na-discuss na yon sa physics for engineers. So let's start with the equation A is equal to dv over dt. Ayan. So notice here that we can multiply dt sa kabilang side. So a dt is equal to dv. Ayan. And then let's say we have various conditions. At time equals 0, we have an initial velocity, we have an initial position xi, and then we have an initial acceleration. And then at time equals yung t, gawin na lang natin at the initial time. So ti. Ayan. And then sa final time, let's say we have achieved a final velocity, tapos meron tayong final position xf, and then final acceleration. Ayan. However, for these assumptions, we are considering acceleration to be constant. So the initial acceleration and the final acceleration will just be equal. So for uniform acceleration, we can actually derive a formula. Now the difference between the final position and the initial position, xf minus xi, this is equivalent to the displacement. So let's say delta s. So now we can integrate both sides. So this is we are integrating with respect to time. So from t initial going to the final time. And then for dv, let's integrate from the initial velocity going to the final velocity. Now our second assumption is the initial time is equal to 0. So again, our assumptions are the acceleration is constant and the initial time is equal to 0. So once we change this one to 0, and then for the final time, let's just label it as t. This will now become t. So integrating with respect to time, this will become at. And then equals, integrating dv, this will become v, and then apply the limits. We have vi going to vf. So apply also the limits for this side from 0 to t. So substituting t for this variable, it will just stay the same. At equals, and then substituting vf for v, we have vf, then minus substituting vi for v, this is vi. So our equation would be expressing vf, we can move this to the other side. So vi plus at. Now this can be plus or minus depending on the value of acceleration. So if the body is accelerating, then this will be positive. If it is decelerating, then we have to use minus. So this is how the first equation is derived. Now for the second equation, we can use this equation and then integrate. Now for the final velocity, let's just also label it as v to make things simpler. So t and v correspond to the final time and the final velocity. So we can just change this one for the purpose of simplification, and then this now becomes v minus vi. So v is equal to vi plus minus at. But still, you can just label this as vf. But once we integrate, it's better to have this equation. V is equal to, again, just change this one to vi plus minus at, or just simply plus. Now we know that dx over dt is equal to the velocity. So we can just use this equation. This is vi plus minus at, and then we can multiply dt to the other side. So this is now dx is equal to vi plus at. Let's just add the plus or minus later, and then we have dt. So when integrating, let's apply the limits. This is for the displacement. Integrating dx gives us x, or simply s. If you want to change the label, you may replace this with s. So this is from x1 to xf. X initial to xf. Then for this one, we are integrating with respect to time. So from time equals 0 to the final time, t. So integrating dx, this would be x, and then equals, apply the limits first. So xi to xf. Then vi plus 80, integrate with respect to time, it will become vi, this is a constant term, so vi times t, then plus 80 plus 1 sa exponent, so squared, and then divide by the exponent, 2. And then apply the limits from 0 to t. So this now effectively becomes xf minus xi, and then equals, substituting 0 to this equation will just give you 0. So what's left is vit plus 1/2 80 squared. And then xf minus xi is just the displacement. So we can replace this expression by delta s. So this is now our second equation. Now for the last equation, we need to apply the chain rule. So try to recall that the chain rule states that if a variable y depends on another variable u, which in turn depends on t, then we can describe it as dy over dt is equal to dy over du multiplied by du over dt. This means that to differentiate y with respect to t, we first differentiate y with respect to u, then multiply by the derivative of u with respect to t. Now we can relate this to the acceleration equation. So we know that a is equal to dv over dt. However, if we treat velocity as a function of displacement instead of time directly, we can apply the chain rule. So dv over dt is essentially dv over ds. So our function y is essentially the velocity, itong dalawa. And then du corresponds to ds, because velocity is a function of displacement. And then multiply this by du corresponds to ds still, and then over dt. However, notice that this expression is just simply the velocity, because velocity is equal to ds over dt. So here, you can just verify because ds will cancel, and then dv over dt is just equal to dv over dt. And then let's turn this back to acceleration. So a is equal to dv over dt. But let's remove this one, and then let's change this to v. So a is equal to v multiplied by dv over ds. And then we can multiply ds to the other side. So we would have ads is equal to v dv. So we are to integrate this with respect to s, while this one with respect to v. So our limits for this, since s corresponds to the positions, so this is from xi going to xf. And then for v, we are integrating with respect to v, so this is from the initial velocity going to the final velocity. So let me just remove this, and then let's bring this up. Integrating ads, it will become as. And then we have to apply the limits, xi to xf. And then equals, integrating v, this would become v squared divided by 2. Then apply the limits of vi going to vf. So this would now be a times xf, and then minus a multiplied by xi. Just substitute the variables for s. And then equals, substitute vf. So this is vf squared, then divided by 2, minus, substitute vi squared divided by 2. Now we can simplify this equation. We can multiply this by 2 and do the same for the other side. So times 2. And then notice here that we can factor out a. So this is now a, and then multiplied by xf minus xi. Then we have 2 sa front. And then equals, this will cancel. We have vf squared minus vi squared. Now xf minus xi, that's just the displacement. So we can replace this with delta s. So 2a delta s is equal to vf squared minus vi squared. So you might be familiar with the equation, which is vf squared is equal to, just move this to the other side, it will become plus. So vi squared plus minus 2a delta s. So this is now our third equation. So itong tatlong equations, ito yung gagamitin natin para sa problem application. So you may just memorize the following formulas. However, let me clarify that in some books, this is just labeled as S, and also this one, instead of delta S. So let me just change the labels. Gawin na lang natin S, and then ito rin. Ayan.